Hey guys, here we are in lesson 3, video 1, and we're going to be working on classifying parallelograms based on their properties. And here we have a conjecture, a statement, and I want you to think about whether it's true or not. All parallelograms are quadrilaterals, but not all quadrilaterals are trapezoids. Okay? Can you put in Edpuzzle whether you think that is true or false? We're going to be talking about it this whole lesson. So go ahead and put in what you think it is. And if the statement had only said the first part, all parallelograms are quadrilaterals, then that'd be a lot easier to agree with, right? Less to think about. Because all parallelograms have 4 sides and have angle measures that sum to 360. So all parallelograms are quadrilaterals. We're going to explore the second part of the statement today, and we're going to learn properties of parallelograms and compare their properties to the properties of other quadrilaterals, right? Remembering that properties are the attributes of everything in that category, right? Okay, awesome. So what we're going to start with is we're going to construct a parallelogram. All right, so very similar to how we constructed a trapezoid in lesson 2. And you're going to need an index card or some kind of a straight edge and a ruler to help you out with this. What does a parallelogram have to have? Has to have 2 pairs of parallel sides, right? Opposite sides of a parallelogram are parallel. So you want to make sure that your opposite sides are parallel. You can use your straight edge to draw the bottom line, right? And then, you know what I like to do is then draw the top line parallel to that line. And you can measure with a ruler if you want it to be perfect, which it should be pretty close to perfect as we can get it, right? So then we have 2 parallel lines there. And now we want to connect those with 2 parallel lines. So it's okay if your parallel lines kind of cut off. What I mean by that is if you have this little extra part here, right? That's okay. We're just going to make our parallel line there like that. And then I want to double make sure that my next parallel line is going to be exactly parallel to that. So I could measure the distance going across. I could use my index card. See how I'm using my card here? So I put it the width of the card. So then I know that those 2 lines are parallel. So you could do that if you wanted to. So here's my parallelogram. If you don't have your parallelogram drawn yet, then pause the video here and finish drawing that parallelogram. Okay, so in the previous lesson, some of the quadrilaterals we made had only 1 pair of parallel lines, right? Some had 2 pairs of parallel lines, but they were all trapezoids, right? Because a trapezoid has to have at least 1 pair of parallel lines. So today, the quadrilaterals we constructed that we just made, right, have 2 pairs of parallel lines. So they can be classified as parallelograms. When can a trapezoid also be classified as a parallelogram? If it has 2 pairs of parallel lines, right? A trapezoid only has to have 1 pair, but a parallelogram has to have 2. Trapezoid can have 2, but it doesn't have to, okay? And there's a lot of different parallelograms. Okay, so we each drew our own parallelograms, and here's some example parallelograms. Some things about the figures that are the same and some are different, right? What property do they have in common that makes them all parallelograms? 2 pairs of parallel sides, right? So you see that here's a side and here's a side, and they have the arrows, right? And these 2 will go on forever, and they're never going to touch. And then these 2 are going to go on forever, and they're never going to touch. That makes them parallel, right? Two pairs of parallel sides. What do you notice about the side lengths of the parallelograms that we have here? You see? You notice something about the side lengths? Right. The opposite sides of parallelograms always have the same length. Okay? But let's look at some more examples. And I'm going to need to open this. Let's see if we can get to it quickly. All right, so here we have a, it's called the Geometry World Side Length Explorer. And we're just going to look at the side lengths, right? And we can make it fly back. All right, so let's make it into a parallelogram. Okay, let's make opposite sides parallel. Not always trapezoid. We want always parallelogram. Yeah, it doesn't seem to. Maybe they're not quite parallel. There we go. Okay, always parallelogram. And you can see that the opposite sides are the same size, right? Now let's make, now that we have it set on always parallelogram. Oh, look at that. It'll grow and change as we, right? And you see the different colors. Okay, so that makes sense, right? Because if it was a square, then the opposite sides would be parallel. I mean, parallel and the same size. If it was a rectangle, the opposite sides would be parallel and the same size. So it's the same thing if it's a parallelogram. We're just, what would you call it? Bending it over a little bit, making it a little bit crooked, but the opposite sides are still parallel and equal to each other. Okay? There we go. All right. So now let's look at these. If a parallelogram has right angles, you see there's one with right angles, is that an attribute of the parallelogram or a property of all parallelograms? Attribute of that particular parallelogram, because not all parallelograms have to have right angles, okay? What do we know about the angles of every parallelogram? Think about what we talked about with the trapezoids. The interior angles, the inside angles, always are going to add up to 360. That's the same for trapezoids, and it's the same for parallelograms. And trapezoids also have two pairs of supplementary angles, right? Okay, so now we're going to take our our parallelogram, and we're going to label the interior angles like we did with our trapezoid, and we're going to measure them with our protractor. So good practice using protractors. Remember that it's left is A, right is B, right is C, and left is D. Just like here, you're going to go around A, B, C, and D, and then you're going to measure those with your protractor. Pause the video so that you can do that. And then we're going to continue looking at our parallelogram. And we notice that opposite angles in the parallelogram have the same measure. Do you see that? 117, 117, 63 degrees, 63 degrees. Did your parallelogram that you drew come out the same as that? Make sure you have it, because I'm going to ask to see it when I do your mastery check. Okay, so make sure that you're doing it. If yours doesn't come out to exact, It might just be because when you drew it, it wasn't exactly perfect, right? But it should be pretty close. Do opposite angles in trapezoids have the same measure? Not necessarily. It depends on the trapezoid, right? If the trapezoid is a parallelogram, then it will be true. Where in the parallelogram do you see angles that are supplementary, that add up to 180 degrees? Do you see that? On this one, we see 117 plus 63. That's going to equal 180, right? So A and B, B and C, C and D and A, right? So opposite angles always have the same measure. So supplementary angles are going to be the ones next to each other, right? Okay. All parallelograms have opposite angles with the same measure. Is this a property of parallelograms? Yes, it is. It's true of all parallelograms. Having opposite angles with the same measure is a property of all parallelograms because it is true, right? For all parallelograms. It's not a property of trapezoids because it's not true for all trapezoids. Okay, so think about a trapezoid that is a parallelogram and a trapezoid that is not a parallelogram. All right, you're doing awesome. Let's check out our animal video. Animals and children.
Oh my God. Wow. So funny. Doing like this. Oh my God.
Okay, more on that later. Thanks for all your hard work.